Hello and welcome, everyone. Thank you for joining us for today's fireside chat. My name is Damaris, and I'm a training and education consultant at Enor. Hello and welcome, everyone. Thank you for joining us for today's fireside chat. For those of you who don't know us, Enor is a leading global Google Cloud and Google Marketing platform partner. We specialize in data engineering, data science, and data visualization. Today, we're presenting Machine Learning Essentials for Marketers and Analysts with Justin Marszewski, our machine learning engineer. I'll tell you a bit more about him in just a second. So just a little housekeeping before we get started. If you have any questions during the webinar, please type them into your YouTube chat. We'll bring them up as we go along, and we'll probably also have time for questions at the end. This is a friendly webinar and a friendly conversation, and we want you to ask questions, chime in, and get involved. Our presenter today is Justin, a machine learning engineer at Enor. Justin uses predictive modeling and machine learning techniques to find insights for some of the world's largest companies. He studied finance and mathematics, and earlier today we were talking a little bit about the projects and the tools he's working with, and I got a long list of platforms like R, Shiny Server, Docker, Python, and Google Cloud Platform, and many more. So we have a lot to talk about, and we're going to jump right in. If you're joining us today, you probably already know that everyone is talking about machine learning. As an educator and trainer, I find this topic fascinating. I'm excited to explore it with you and with all the marketers and analysts joining us today. Welcome to the chat, Justin.
Thank you, Damaris. Really appreciate that introduction. It's a pleasure to be speaking with everyone today. Thank you for taking the time out of your busy day to join. As you said, there's lots being said about machine learning and artificial intelligence, and it's really clear from what you've probably read and seen in the media is that this is a pretty polarizing topic. You know, looking at some of the words of some of the world's top business folks, like Mr. Bezos, who predicts we'll have a wealthier civilization, while Mr. Elon Musk says we should be worried, more so than about North Korea. And Mr. Gates also has his concerns. And then finally, the late, great Mr. Stephen Hawking goes as far as to suggest, being said about ML, one of my goals is to help cut through the hype and help marketers, analysts, and everybody that I work with understand the definition of machine learning, where it intersects with marketing, and then talk a little bit more about a specific use case.
That sounds like a great start.
Good. Well, kind of starting with the hype, where are we? I think, and well, kind of pulling my what I think from Gartner, someone who's way more on the button about these sort of technologies, is that deep learning or AI, machine learning, we could be at the very top, the peak of inflated expectations. And you're probably thinking now, you know, what is machine learning, deep neural nets, you know, reinforcement learning, all of these buzzwords and technologies. And you're probably wondering, well, what is machine learning and how does it really apply to me as a marketer? Well, first we'll start with a basic, maybe more fundamental definition of machine learning. So machine learning is probably best defined as an area of AI or a subfield of artificial intelligence. And that's the ability to learn without being explicitly programmed. So in machine learning, we make models from input data that create a useful output. And the most useful output is predictive analytics or predictive modeling. Now again, looking to that visual on the right, we can see how ML relates to AI. It does not exactly equal AI. And to peel a little bit of a layer back on the artificial intelligence buzzword, all of the AI we have now is not sentient or Terminator, Skynet, self-aware technology. What we have now is what's called artificial narrow intelligence. AI uses lots and lots of data to do one thing: to ID candy bars from images, detect faces in photos and videos for Snapchat filters, recommend products or songs you're likely to buy from you or others browsing and listing history. It takes millions and millions of examples of this data, to train these models to make the predictions.
Mm.
And so on the other hand, artificial general intelligence is academically defined as the ability to achieve complex goals in a difficult environment with limited computational resources. So I didn't put that definition up because it's pretty complex, and really we're quite a long way, likely quite a long way from this, where you wake up in the morning and your Jarvis or your Skynet or whatever your computer is called would make your breakfast for you and already know what you want. So that is, we're quite a ways away from there. But getting back to the subfield of machine learning and why everyone likely joined today, one of the ways I like to describe it is using data to answer questions. And this could be thought of as a bit of an oversimplification, but I still think it's pretty useful. And we can kind of split this description into two pieces. Using data, which we also refer to as training, and then the second piece would be the answering questions. And we can refer to this as making predictions or inference. And what connects these two parts together is our model. We train the model to make increasingly better and more useful predictions using our data. And this predictive model can then be deployed to serve up predictions on previously unseen data. So you're probably wondering, well, that's great, but where does this intersect with marketing?
Mm.
And many places. Machine learning can be applied to many of these use cases throughout marketing. And I can't take credit for this amazing diagram. It's from a blog post, not an eNor blog post. But it's a really, really great illustration of the most common use cases for marketing. And I won't spend time going through all of these, since depending on what kind of industry our attendees are in, or the projects you're working on, some of these will be more applicable than others. Some of my favorites are looking at customer churn, where we can predict the probability of, say, a customer to churn next month, so then we can proactively reach out to them this month. Customer lifetime value is another one of my favorites, where we can say, of these new, of the new customers we acquired this month, can we predict, their future value to us? How much can we expect to earn from these customers? Are they high value or low value? Also, another favorite is recommendation engines. This is the Amazon recommended products, the Netflix recommended shows, the Spotify playlists that go on after yours. And this is some really exciting, cool stuff that's related to your history of browsing websites or interacting with applications, and also the patterns of others. And one of the last ones that's my favorite is around segmentation and targeting. And I think this is really important because it really helps us create solid customer experiences and not annoy our customers with too many advertisements. So this one I'd like to talk a little bit more about and go through a specific example around a lead generation. So here's an overview of a challenge and a solution related to remarketing for a lead generation website. And I know there's a lot on this slide, but we'll go through it all, and there'll be time for questions, of course. And I want to try and keep this maybe a little bit more simple and not too technical, because we don't have a lot of time today. But I'm hoping that this inspires good questions and the ability for you to apply and expand upon this for your own use cases. So essentially, our challenge that we're proposing here in this hypothetical is minimizing our cost for conversion for new leads as remarketing campaigns. We want to try and use our GA data to do this. Remarketing users that visit just to a form page is a good signal of high intent and a good place to start, but how could we go beyond that? How could we improve that? Because if we just use this criteria, we could be remarketing to too many users and wasting spend on users that are likely to convert anyway. Say they got interrupted and we're planning on coming back, or first-time visitors that were just checking out the form to see what it was about or what information they needed to gather. So you're probably thinking, well, how would we figure out the best combination of these on-site or factors to use in our audience? We could try manually doing this over time based on all the awesome GA data that we have available, but it would be time consuming and cost us money to test this out. So this is where machine learning predictive modeling can help. We can first create a user profile from our historical data of users from our GA360 data set in BigQuery, for instance. We can then create a predictive model using R in RStudio, my favorite, for the math part of this, for lack of a better term, to predict a conversion, which is a form completion. And once we have our model, our predictions, we can then look at our model and examine why it works. And when we examine why it works, we can then take the inputs that we used and say, okay, these are the most important, this information is the most important in making predictions. So these are essentially the most important signals or indicators of conversion. In our hypothetical example here, this would be viewing page A, clicking on a banner, and maybe visiting 4 times. So once we have this once we've done this analysis of our model results, we can then create a GA advanced segment of essentially a lookalike audience. And these users would be users that behave very similar to converters historically, but did not convert. So in summary, our model can say, or we can say our model identifies all users who see page A, click on the banner, or visit 4 times as a potential converter based on the analysis on these other users in the past. And this is why it can be really important to use an explainable predictive model that can show us how it works. A lot of the more advanced research and models that are being used today are more difficult to interpret and understand, kind of like trying to explain why your brain can recognize the difference between a cat and a dog. We don't know why, we can just do it because we've learned it. So using simpler models essentially can be more powerful because we can understand and explain why they work and then apply them in the real world.
Makes sense.
And I think this diagram is really cool and I like it, but it really doesn't reflect the nature of or the reality of how this sort of process works. This is certainly not inaccurate, but what I like much more is looking at modeling, the modeling cycle, or excuse me, looking at modeling as more of a cycle. And this diagram is essentially the same as the one we saw before, but it really demonstrates that machine learning isn't a box check, it's a journey. And actually Google says this, I can't take credit for that, but machine learning is a journey. It's an iterative, cyclic process that could take days, weeks, and maybe 20, 30, 40 more laps around this circle to create a useful output. Then most of the effort is in the front end of defining the objective of why we are doing this modeling project. What is our metric for success? How well does our model need to perform? And then all of the preparation of the data and that the first step or arrow in our top right diagram up here. That's where a lot of the effort is preparing the data for modeling, which is really fun, but unfortunately not where most data scientists spend their time. It's in the requirements and data preparation. Mm-hmm. And Damaris, you and maybe a few others are probably wondering, well, how do I know, or when can I decide when it's worth kind of digging in and going through this process that could take, 30, 40, 50 times, days, weeks? And I'm about to show one of my other favorite diagrams, is that really illustrating of starting with a common sense baseline and then improving from there. So a lot of, a lot of clients or a lot of businesses may think that they need, some cutting edge or bleeding edge data science project or model. But the reality is there's probably lots of things that they could do now or with the data that they have to create a common sense baseline. So for instance, in our remarketing example earlier, if a client came to us and said, we want to help improve our remarketing, we would probably recommend, well, just start with the form page. Start there. Start with something that is a good start. and then we can iterate and improve on top of that. Because 80% of the value comes from that common sense baseline. And another example would be if, say, you're an e-commerce company and you'd like to create a recommendation engine or an area on your site to upsell customers on products that they're likely to buy. One of the simplest ways to start is just create a widget that shows the top selling products. And then that gives you a good baseline to improve with a model, because a modeling, that modeling process, as I mentioned, could be a cycle, and it's hard to pin down how long that could take. But getting 80% of that value of just engineering a solution and understanding the objectives will get us there. And then that's when the data science come in, is when we want to improve upon basic engineered solutions. And that's when we can really see the value and the coolness of machine learning.
Yeah, and we have one of our audience members commenting on that. They love the common sense baseline idea. And, I think it's interesting that as much as our technology is advanced, it's always so important to start with clear objectives and even determine, which are the most important problems worth solving.
Excuse me, I was choking on my water. But yes, you're absolutely right. 80% of the value is in those engineered solutions and understanding and defining the problems. And I think that really wraps up I didn't want to bore everyone to death with the PowerPoint. So yeah, does that make sense, Damaris? What do you think about the process and the common sense baseline?
It does. And I think these examples, especially the retargeting, remarketing examples, are so relevant for marketers today. I think, I'd love to get into some more examples. Before we do go there, though, I'm curious about the human behind all of this. And I'm curious about you, Justin. How did you get into this line of work? Like, what's your story, your background?
Oh, good question. So it's very ironic that I got into this space or industry by pure chance. I actually found a consulting firm offering a marketing statistics internship, from my university's job board while I was taking post-grad classes. I did want to go back to school and get a master's degree, but this internship was so intriguing. And long story short, I turned the internship into a partnership. And my business partner and I had a small team that we helped design and implement email marketing campaigns for e-commerce clients. We basically helped design the flow, like the win-back emails of, you would email purchasers and, hey, try this shirt. You bought the pants. Or, hey, we haven't heard from you in a long time. Here's a coupon. Sort of designing that and then also implementing it through a lot of manual SQL and Excel work. So MailChimp was the email platform I used, SQL database. So I really kind of got thrust into the industry through an internship that really set me on the course for where I am today. And I think the two pivotal moments in my career were when I did teach myself SQL just on my own. I needed to use it for a project. I think I spent like 80 or 90 hours in a month, non-billable on my own. I tracked all my time, of course, just teaching myself SQL. And that was really paid off in the long run because, it's still, after 20 years, SQL is still a very important fundamental technology that we all use. And then the second, I guess, pivotal point in my career, how I got here, was when I forced myself to use R instead of Excel. So they had just deleted Excel. I was so tired of retracing my steps and version control that I said, I don't care if it's going to take me 3 hours to make a plot with R, I'll do it instead of Excel. So that really set me on the course for, getting into the programming languages and, all the technical code stuff that I work with on a daily basis.
That brings me to a question that I get a lot, and one that I got from several marketers leading up to today. And it's good to know that you have that background in marketing. I'm a marketer at an enterprise company. How much do I need to know about machine learning?
Really good question.
Mm-hmm.
Yeah. So I think we talked a little bit about it, but I think there's a lot of hype, as I mentioned. there's a really high level of expectations that predictive modeling, machine learning can solve all the problems. I think the one thing to not get too philosophical, but the most successful projects and clients I see view data as an assets. View their data as an asset. You can get value from existing data that you have, but really the most value and impact on the bottom line is when you start with your objectives and then work backwards to collect the data that you need and then view that as an asset. And I think specifically as a marketer, what you would need to know to kind of cut through this hype, besides seeing data as the asset, is really understanding the basics. I think, not to say you need to learn to code or anything, but, getting your hands dirty a little bit with some 101. Google has a great crash course in machine learning that'll give you the basics to understand the key terms and how the projects work. But don't take my word for it. Even Mark Cuban said recently, if you go in my bathroom, there's the book, Machine Learning for Idiots. Whenever I get a break, I'm reading it. So just understanding a little bit, a couple, maybe one or two layers deep would just be really helpful just to kind of understand that, machine learning isn't magic. It's a scientific process that's getting easier with all the amazing technologies that Google, Amazon, all the framework, open source technologies that are available. But it still just requires good hard work by humans. And kind of like I said before, of understanding and defining the objectives of, the silly questions of why do we have a website? Why do we pay for GA360 or this expensive analytics tool? So really starting there, and then going one little bit deeper into the technical, so you can just kind of understand a bit more and be able to work with your fellow teammates.
That's helpful. And it looks like we have a good question here. Let's see if we can tackle this one. One of our audience members here is asking about different learning models. Evolutionary and deep Q come to mind. Where did you start and how or should you start? Is there an obvious best fit for web folks is the question, given you are using R versus Python, for example. Do you have any comment on that?
Okay, sorry, could you repeat the question? I want to make sure I'm understanding. Yeah.
Sure. So the question is, I know there are different learning models. Evolutionary and deep Q come to mind. Where did you start and or how should you start?
Oh, good question. I might have to think about this one a bit more. In my experience, I learned the tool because of the problems I was facing. So it was, I had a client project or I had 10 client projects and I needed to scale myself or set up workflows that were, I could do them for, 10 people or 10 clients at once if I needed to. So it was kind of by, I guess, solving problems. I can certainly follow up on that question. I don't think I answered it fully.
That's okay. And we are going to share our contact information as we get to the end. So we're happy to connect with anyone who's on the webinar today. I think another interesting place to go now is that there are, and working with clients and this is so new, there are different expectations, what it takes to work on these types of projects. And I wonder your thoughts on some of the challenges for marketers and analysts, just digging into these challenges.
Yeah, really, this is a really good one. I'll try and not ramble on too long. If you think back to your high school or college where you had like word problems in math classes where everything was, fully defined, and, if you were in a computer class or something, you would have this data available already. But that is, I guess, the biggest challenge is getting that data ready for modeling. That's, again, 80% of the work. So specifically with web or digital analytics is the data quality. It's by nature, it's messy, and it's really difficult to make sure your data that goes into GA is clean and how you need it. It's just inherently messy. Browsing behavior is messy. And for machine learning projects, having a robust user ID or a unique user identifier and an authenticated experience is really sort of the minimum for the most useful machine learning projects, because that allows us to join the data with other data sets, since of course sending PII data into GA is a big no-no. That makes it available to join on other data sets, and also allows us to act at the user level. So if we make a prediction, we can go in at a user level and say, okay, this person is not likely to convert. We want to remove them from an email campaign. Or this person is highly likely to convert. We don't want to waste money on them because we know they're going to come back. So it's really applying those predictions and those actions at a user level. Of course, again, not a PII level in GA. But I think, yeah, that's a big one. Same with like the page paths and events, making sure that data is clean. If it's not, it can really add time to those laps around the circle that I showed earlier. If there's a lot of time required in, just preparing and cleaning up that data for modeling. And then I think secondly is unrealistic expectations, that machine learning is magic. So, I think maybe I've heard some folks say that it sounds like they just want to shove all of their 200 custom dimensions into a model and expect them to tell them what's important for their business. So that's not the case. Again, still requires, good human input, good hard work in defining the objectives and then what inputs to go into our models.
Yeah, I love that. I love that comment, Justin, because I do, it is a scientific, it's kind of like the scientific method. It takes time and commitment to that process and those cycles.
Yeah.
And that's a new way of thinking in some, in some instances. It's challenging. We have a question here. I don't know if this might be a little tough to say, but what's your favorite retailer marketing story as it relates to ML and AI? I don't know if you can touch on that a second.
Oh, my favorite story. Gosh.
Or like who's doing it well?
Well, Amazon, of course, they of course do it very well. Gosh, man, that's a really good one. There are, I think this is sort of like probably is the experiences that, because I can identify more problems than I can easy, because when customer journeys experiences are easy, you don't think about them, right? It's only when there's problems or issues that you sort of complain and you have mental friction. So gosh, it's so hard for me to sit here and think, of an amazing user experience that I've had recently. Like the Amazon, again, they do really well with recommendations because they're using all of your data and then everyone else's data, to kind of show, oh, if you're looking at, outdoor, like I'm building a planter box. So like sprinkler equipment and all that stuff, I'm now seeing tons of that stuff, and that's sort of a big obvious one. But I think Amazon really, in my mind, has done an increasingly better and better job at just recommending products. So that's the one that comes to mind. I'll have to think on some more. I know I have a few more.
Okay. Another thing about this is that it takes a team to do this work. Obviously, there's an entire, workflow and so many steps involved, and you showed that great diagram. In your experience, what are some ways to work effectively with someone like you, with a data scientist or ML engineer? These projects can sometimes be complex. They take time. Do you have any tips?
That's really good. Yeah, I'm going to use a silly analogy, but it's kind of like baking a cake. You get out of it what you bake into it. If your team are working with the technical folks, data science folks, ML engineers, is really helping provide them with a clear vision of the business objective and the desired outcome. So the finished cake, what it looks like, where's it going, a wedding, birthday. They also need the good tools, the kitchen, the oven, which isn't necessarily your responsibility as the marketer, but most of all is the data, the good ingredients. The data that we collect with GA, and then of course other sources as well that we can come across from third parties of advertising spend or maybe even CRM data. But technically speaking, this would be around the framing and requirements of deciding what problems are worth solving with machine learning, or which problems are worth spending the time, and sort of trying to map out, okay, if we spend 2 months doing this and we're able to increase conversion rate by X%, what's that mean for the business? So trying to think through the end, that really helps, can help the technical folks really focus on the science piece. And yeah, I think that in case in point of helping, one of the best ways is to have good analysis or good analysts, because they can, again, help the data science folks focus going deep down the rabbit hole of the best scientific solution. And then the analysts can help, communicate the business objectives, help the scientists folks summarize and find the inputs for our modeling, or figure out, what things mean through a data dictionary of, okay, we've got 200 custom dimensions. What do they all mean? How long have they been implemented? What are some sample values? Really helping, the science folks keep on the science. And I think on the flip side is there is a misnomer in the data science world that you're going to be spending all your time coding and doing modeling. So if your scientists are pushing back and feeling that way, that's not a good sign. Excuse me. Because the scientific process includes everything: business, math, and programming. So your teammates should be willing to be involved in those conversations and help define requirements, but just really taking that burden away from them driving and leading those efforts, I think is one key to success in my experience.
Those are really good tips, really helpful for thinking through collaboration and how it takes everyone's participation. We have another good question, and I think this may be the last one we're going to be able to take. It's about interpreting models. Mm-hmm. And the question is, Justin, you mentioned earlier, it's important to interpret models to understand what the signals are that lead to conversions. Do you have any advice on how to interpret models?
Oh, yes, this one's good. So I think the best analogy I can make at first is using a high volume of high quality data with a simple explainable model trumps using, dirty small amount of data with a complex model that you can't explain. And I think when you're interpreting, the more simple models, I think there's plenty of best practices out there, and I think it might be too technical of an answer. But yeah, I think if you're in a situation where I want to, I'm trying to achieve a business objective, trying to get this model to a certain accuracy, but also a byproduct is I have to explain this to everyone, you're going to have to choose the simpler model and the one that's probably less exciting. Yeah, and I think that's probably the best answer I can give without digging into super technicalness. So hopefully I answered that question. Again, I can follow up and think more about that one.
Yeah, high quality data and a model that you can explain, right? So it's understandable.
Yes. And there's a saying that, again, not by me, but you have to get up pretty early in the morning to meet linear regression, which is like what you remember from high school of y equals mx plus b, a line on a graph, trying to plot or touch as many points as possible. That's a very fundamental concept that can be applied to many business scenarios, and it's very explainable. So, that's sort of, it's very tempting to use some of these more complex and nifty tools and cloud services. But again, if you can't explain why something works, you're going to have a lot harder time getting that model deployed and acted upon.
That's good advice. It looks like we've covered all of our questions. Justin, is there anything you want to add or cover before we wrap up here?
No, I don't think so. I really appreciate everyone's questions, and yeah, I think this was really fun for me. I don't have anything else to add at this point.
Great, thank you so much, everyone. We appreciate you joining us today. If you signed up for this webinar via email, you're going to receive a link to the recording in an email. If you'd like to learn more about how machine learning, data engineering, and digital analytics can help you reach your goals, please reach out to us. You can email us at info@enor.com. You'll also see our emails and Twitter handles here. We would love to speak with you. We thank you for your questions and for joining us today. And we'll see you next time.